Okay, so I'm going to be showing a couple of demos I've got here for the E1 EVK. Both of them use just my laptop's webcam or microphone, and then all the data processing happens on the E1's fabric. So this first one's called the Hum Sentinel, and basically the laptop just streams 8 kilohertz of audio to the E1, and then the E1 learns the baseline frequencies of the room, and then runs a FFT algorithm and basically just reports back anomalies that were detected. Each demo has a dev mode and a deploy mode. The dev mode shows more data, like this one has a spectrograph, and it shows you like the frequencies that are specifically being detected. And then deploy mode just shows the events and how many have been detected. You can see we're trying to get some high frequency here. The application also shows the usage, like the power usage output from the eval kit. This demonstration I noticed would normally get around 2.6 milliwatts out of the E1X. We can also inject sound just by holding down certain keys. So here I'm just injecting this kind of like voice frequency, and you can see that the E1 learns that would be part of the room's hum, and then those frequencies no longer trigger an anomaly, but the high frequencies do. So this example breaks down the sound into 128 millisecond chunks. For the scalar build that just runs on the RISC processor, it's 8.26 milliseconds per chunk on average, and then the fabric runs the process at about 2.08 milliseconds, so it's about 4 times faster on the fabric. All right, so now we'll move on to the meter reader, which is meant to be an optical analog gauge reader, basically. It uses the laptop's webcam, and the laptop handles the cropping of the footage. So you'll see here, it's down to a 64 by 64 grayscale image, and then it sends that to the EVK through USB-C. The E1 itself on the data flow fabric runs the denoise, normalization, and raycasting to find the needle. You can see we can kind of decide the size and positioning of the gauge here. And here in dev mode, we can see the scores and kind of what the E1 is thinking. Here with my rudimentary paper with a line drawn on it. This one also has a dev mode where only the result, basically the position, is sent back from the chip. And I noticed that this demonstration runs at about a milliwatt more power draw from the E1 than the previous demonstration. And then in this case, the scalar build actually ran about 10 times slower than the fabric did. So there's a pretty big performance difference here between the two. It was 7.39 milliseconds for the scalar and 0.76 milliseconds per frame for the fabric.